Okay, so our goal for this unit is we're going to take some right angle trigonometry and we're going to put it on a coordinate plane. So we're going to put it on an XY axis. All right, so here's my XY axis. This would be my initial arm. So my angle, you guys would agree, would be in there. I'm going to use a fancy highlighter. That is the initial arm. It's where it starts. So it's where the angle starts. The terminal arm, anybody want to guess where that is? Where the angle ends. It's the other arm. Where's my green highlighter? Okay, so it's pretty straightforward when things happen in coordinate. Do you guys remember labeling what quadrant is what? You guys remember that? Of course, silly me. So you guys know that this is quadrant 1, that's quadrant 2, that's quadrant 3, and that's quadrant 4. And for some reason in math, we love to label them with Roman numerals. I don't know why we feel the need to do this, but we do. And feel free to use regular numbers. I won't lose my mind over that, but just know that they usually do that. Okay, here we go, ladies and gentlemen. So this is going to be some new things. You've always measured angles in degrees. We're going to add a new type of measurement. It's in radians. Each radian is bigger than a single degree. All right. Already, we haven't even done anything with them, and you're like, I'm out. You got this. Perfect. I love that. We're also going to measure angles in positives, and we're going to measure angles in negative, and it's about the direction. It's about the direction that the angle is being measured in. Okay, so positive angles are measured in a counterclockwise direction. Ooh, forgot an I in there. Counterclockwise. That's the abbreviation that we use a lot. So if we go here, and let's make this angle, I'm going to make it 30 degrees. I'm going to say that that angle in there is 30 degrees. And all of our lives, we've only ever dealt with positive angles because we've never put them on a coordinate plane to have direction. So this would be a measure. We measured from the initial arm, which is the positive x-axis, and we've measured counterclockwise. We're traveling counterclockwise to the terminal arm. So it's 30 degrees, right? That's the world we lived in. Now we're expanding your world a little bit better. So negative angles, anybody want to guess which way we measure them? Clockwise. Nope. Still measure from the same spot. All right. So I still have my positive 30-degree angle here because I'm measuring it this way, positive 30 degrees. But the negative angle would come in this direction. What would the negative angle be? Negative who? Negative 330. Because how many degrees are in a full circle? 360. We know that that's 30, so we know what's left over is 330, but we're measuring it in a negative direction. So that's negative 330 degrees. Okay. Not too hard. Not too hard. Okay, here we go. Supplementary angles. two angles that add up to 180 degrees. Okay, what do you think complementary angles are? Adds up to 90. The way I remember it is a compliment is nice, but taking me to supper is better. 90 degrees is little, 180 is bigger. That's the way I remember it. It's not that great, but it works. Like, that's how I remember it. So we have two angles. Now we're gonna work in both worlds of degrees and radians, and it's gonna be super fun. Okay, obtuse angles. Anybody remember? Okay, let's go to acute angles. What are those? Less than 90 degrees. Yeah, so it's just one angle that's less than 90 degrees. And I'm using the Greek letter theta here, and that's kind of a known replacement for just the variable for angles, if you want to write the word angle in there. Okay, is it equal to 90? What are 90-degree angles called? Right angles. So those are very specific, right? So acute has to be less than 90. Obtuse is more than 90, but yes. And I'm not sure where you've learned all of this. Like, I don't know what grade, like I know we did 90-degree trig in grade 10, but I don't know where you learned the names of all these angles. So I'm proud of you for remembering those, because I don't remember where you put them. All right. Okay. A radian it's a unit of measure for an angle. That G is looking a little sketchy. Let me try that again. Okay, so what I mean by it has no units of measure, when I talk about 30 degrees, what do I need? I need that little degree symbol, right? So we know we're in degrees. So this would mean 30 degrees. Sorry, my page is all crinkled here. So that would mean 30 degrees. If I say just 30 and there's no unit on it, guess what that means? 30 radians. Okay, so if you do not put a unit of measure, like if you don't put degrees, I'm going to assume you're talking in radians. Okay, what else can I tell you? I can tell you that how many degrees is in a circle? 360, right? So, I don't know, I'm going to draw you a picture. So we know going around a circle is 360 degrees. The equivalent in radians is 2 pi. Pi. Oh. All of a sudden, pi is going to be a big part of your world.
I thought we were trying to like not make that shade too much.
Exactly, because we're going to do everything in pies.
What?
We're not going to multiply it through.
Okay.
We're not.
Okay.
We're not going to multiply it through, guys. So now we're going to deal in like pies. Do I have one pie? Do I have a half of a pie? Do I have two pies? Yes, that I can do. That I can do. Okay, so in your head, without using your calculator, what's the decimal equivalent to 2 pi? 6.28. So I want you to think about this. Which one's bigger? Is each degree bigger or is each radian bigger? And when I'm talking bigger, like slice of the circle. Which one's bigger? Radians. Because how many radians do I have to go all the way around? 6-ish? How many degrees do I have to go all the way around? 360. So I would like to be part of the radian party where I get a bigger slice out of that pie. Make sense to everybody, kind of, sort of?
So would you say 2 pi or 6.28 radians?
I would say 2 pi. And we're going to get to that. Like, this is where the calculator starts to go away because we're not going to multiply that out. I know we just did, but we're going to stop that. Okay, so this is sad. My circle got cut off. Are you guys, so we're going to fill in the circle. I don't know what happened here. I think my table got a little, things got out of hand. All right, so if this is my initial arm, because remember where the initial arm is, it's on the positive x-axis. We measure all angles from the positive x-axis. That's going to be our initial arm. So that would have a radian measure of 0. Because that would mean my terminal arm is lying right on top of my initial arm. So how far have I gone? I've gone nowhere. But what if I go all the way around the circle? How far have I gone? 2 pi. So it's either where you start, you've gone nowhere, or you've gone all the way around and come back home. So you'll see that this measure is 0 and it's 2 pi. It's just because it's 2 different locations. It's kind of like the start of your journey and the end of your journey. And that coordinate pair would be 0 and 1. Oh, that's a good question. I didn't even explain that. What are we learning about? The unit circle. So what's the radius of a unit circle? The radius is 1. The diameter is 2. You guys don't know that? I'm telling you that. So on a unit circle, it has a radius of 1 unit. Yep. It should be 1, 0. You're right. You're right, sorry. It was there, now I'm all screwed up. Okay, so the other piece that's missing. So, ladies and gentlemen, if this is 2 pi, over here would be a full pi. Like, so half the circle, if you travel all the way over to here, that's pi. Okay? Because you have 2 halves of the circle make up 2 pi, so 1 half is a pi. What is half of a pi? Well, it's pi over 2. So you're just saying I have half of a pi. What's the angle measurement that goes with that? What's the angle measurement? Just look, you guys know this. 90 degrees. Okay, what's the angle measurement at pi? 180. Okay, now this one down here, that I don't know where I'm going to put all this information. What's this angle measurement? Let's start there. 270. Brilliant. Okay, coordinate pair at this point is going to be 0 and -1, right? Okay, what is the radian angle measurement? So you've gone 1 pi. And you've gone another half. 3 pi over 2. Good job. So you got to math it out, folks. You got to math it out. I know nobody wanted to hear that. if you guys know that from here to here is pi over 2, you guys would agree that this angle measurement in here is pi over 2, right? Well, you do now because you know that. That's really hard to see. This is a half a pi. How many half pies do we have to get to here? 1, 2, 3. 3 pi over 2, right? Or I've gone a full pi, and then I have to go another half pi. So then I'm at a pi and a half, right? So that'd be 3 pi over 2. Okay, good. All right, good job, everybody. Way to do math. Okay, there's like a lot more we're going to add to this. So I just need you to be emotionally prepared. Okay, let's get through this table really quickly. The radian measure that goes with 360. All the way around. 2 pi. What's the radian measure that goes with 180? Pi. What's the radian measure that goes with 90? Half pi. Okay. Whoa, now things are getting very confusing. Okay, we're going to math it out. I'm going to pop down to 45 degrees. I'm just going to half of half. So what is that in fractions? 1 over 4 pi. So half of half. Because we know 90 degrees is a half, and we're going to 45, which is a half of a half. So that's pi over 4. You guys are doing awesome. You're doing awesome. Okay. What am I waiting on? Sure we can. Yep. Ah, good job. Pi over 6. All right. So for the rest of us who are not keeping up with the math, Danica said 90 is pi over 2, and I know to get to 30, I got to divide 90 by 3. So that means I have to divide this one by 3. So I'm going to go up here. So pi over 2 divided by 3 is the same thing as saying pi over 2 times by a third, which gives me my pi over 6. Okay, so which one are we going to use 90 to get to 60? No. Oh, so what are we doing with the 30? It's double it. So now I'm going to have 2 times pi over 6, which would give me 2 pi over 6, which is going to reduce to pi over 3. How do you guys feel about that? Not terrible. Okay, what you have just calculated are all the exact values we're going to use in the unit circle. So those are going to be the angles that we use, and we're going to use them in all 4 quadrants. It's going to be awesome. Okay, calculator values. This is super easy. We're going to wait for that for a second. Okay, we can do it. We can do it. What do you want to do?
I just completely guessed that.
How did you? Okay, so let's do it this.
180 is 1 pi, and so.
Okay, so this is what Basil just did. He said, okay, 180 is pi. What do I have to do to 180 to get it to 1? We're dividing by 180, so this would be pi by 180. So all of a sudden, we were doing okay with the little numbers, and then I've asked you to expand it to your big numbers. Okay, do you guys trust? Okay, first of all, everybody needs to get their calculator out. Everybody needs to find their pi button. If you have a scientific calculator, you have a pi button. Pardon? You have a who? X like subscript form?
I
I don't know what that's for.
Oh, yeah. Mine's like a full problem.
I don't know. Okay. So that's the question, where's pi? Like, on this calculator, it's right here. It's in blue above, so I know I have to go second function, and then my arrow key, and it will put in a pi for me. Let me grab a different calculator. And usually, ladies and gentlemen, it is a second, like it's a second key, but maybe not. I'm looking. Anybody see pi on this one? Oh, there it is. Oh, you can't see it, sorry. It's right at the bottom. It's in yellow on this exponential key. So that means I'm going to have to use the shift because the shift is in yellow. So shift pi, and it puts in my pi symbol for me. So you should get away from using 1 or 3.14. You should be using your pi button. Okay, so I'm going to times that by 2. Oh, darn it. Okay, this isn't my calculator. I'm going mode. Mine just gives it to me. It's like, lady, you should know what you're doing. Okay, I'm going to go to this one, times 2, because this is the calculator I know how to use. And I get 6.28, so we're just going to write in 6.28. Pi, what's pi? 3.14. So now pi divided by 2. Well, I'm going to get 1.57. And then pi divided by 3, 1.05, because I'll round. And then I've got pi divided by 4, 0.79. And then I have pi divided by 6, and I'm at 0.52. And then I have pi divided by 180, 0.02. Yeah. So remember that a calculator value is estimated because pi goes on forever, ever, and ever. So this is an estimated value. So if I ask you for an exact value, you have to go back to your radians because this is an exact value. You haven't rounded anything, you've written it down. Okay, we good? Can I flip the page? Yeah. Beauty. All right. Degrees to radians. If you have degrees to radians, so if I give you degrees and I want you to convert it to radians, you multiply by, this is from your table, you multiply by pi over 180. This is exciting. And then you're going to reduce the fraction. So you're going to take your degree, so in this one it's given me 2 degrees, and it wants it in radians. So that's going to be 2 times pi over 180. So we're removing our calculator, right? Yeah, we're removing our calculator. I want this in reduced form. Pi over 90, right? So that goes into that 90. So my answer is going to be pi over 90. Not 90 degrees, because we have no symbols when we're in radians. No symbols. None. 0. Okay. 25. Wah, wah. Everybody's like, ugh.
Can we do it through factors of 5?
Yeah, you totally can. You're going to have to do it through factors of 5, because 25 does not go into 180. You might need your calculator for this, which is okie dokie. To reduce it, I just don't want you to multiply that pi through. Okay? So if you need your calculator to reduce it, I'm not going to give you these big ones. What is it? Over who? Yeah. So it's going to be 5 pi over 36.
Write it like it's in the bracket.
That's as simplified as you put it. Because 5 and 36 don't reduce. Okay, so we got 108 times by pi over 180. So we're going to have 108 pi over 180. I mean, if you got this on a test, these are even numbers, so start with 2's, like half them and then half them and then half them until you get there. It's painful, but you can do it. Because I already have the notes done. I had to pull out the notes just because I couldn't find, I didn't know what was in my, what else I had added to that pretty circle. What, 20, what? Nope, 3 pi over 5. Anybody know what factor I took out? Because all you had to do was take 108 divided by 3, and I'm left with 36, and that would be the thing that I would have had to take out of both the top and the bottom. Okay, so now going the other way, we're going radians to degrees. So no units on radians. So all these answers here are in radians. So those are all in radians, and we're not going to put units on them. They stay like this. All right, you good? Okay, radians to degrees. You're going to do the reciprocal. You're going to multiply by the reciprocal. Okay, so we have pi over 4 times 180 over pi. What can you cancel out right away? Definitely the pi's are gone. And how many times does 4 go into 180? 45. It's okay. But my answer is now in degrees. I just converted it to degrees, so what do I need? I need the actual symbol, right? So critical here, now that you're dealing, it's kind of like dealing in kilometers and meters. It's so important that you put your units of measure so that you're accurate in what you're doing. So I have 3 pi over 2. You guys should be able to do this one from the table that we just did. No? No? 270, yeah. 3 pi over 2 is equivalent to 270. We just did it on the circle on the other page. That's why it pops off the page. Okay, so what are we going to cancel out? Pi's. How many times does 2 go into 180? And then 3 times 90? 270. And again, I need my degree symbol there. Okay, so this one is an approximate one. So if you're doing approximates, you need your calculator. You're just like, thank God. You're still going to do the same thing. You're just going to use your calculator for this one. So 1.53 radians times by 180 divided by pi. Okay, don't forget to use your pi button. Okay, so what are you going to do first? Are you going to multiply or are you going to divide? Does it matter? No. I'm going to multiply first. So we get 293.9 degrees.
What are the rounding rules for like?
Usually 2. like when we're dealing with angles, we usually go to the nearest whole degree. For lengths, we go 2. But you know you don't round until your absolute final answer, right? Okay, we good? Can I flip that? Nicole, are you good? Okay. Oh my God, there's so much today. Okay, complementary and supplementary angles. Complementary angles add up to what in degrees? 90, right? Complement's nice, supper's better. So complementary angles add up to 90. What is that in radians? Pi over 2. Supplementary angles add up to what? 180. What is that in radians? Pi. So I'm going to ask you guys to memorize these places along, and I'm going to say memorize. I want you to learn them, but you've done so much in degrees for all of your life that sometimes you're just going to have to memorize what the radian equivalent is for them. Okay, here we go. Find the supplement of 3 pi over 4. So what that means is 3 pi over 4 plus something equals supplement, so it's going to equal pi over 2. So I'm looking for this. So that's just like saying x. How would we isolate x? We'd move this to the other side, right? So question mark equals pi over 2 minus 3 pi over 4. These are fractions, so what do you need? Common denominators. So question mark is equal to 2 pi over 4 minus 3 pi over 4. Oh, okay. So what do I get here? Oh, guys, are we adding to supplement? Or what did I just do? What did I just do? I did the complement. Supper's better. So does it equal pi over 2? It equals pi. Oh. Scallion. Scallion here. Let me just get rid of that line altogether. Okay, so it's equal to pi. So now I got question mark equals 4 pi over 4 minus 3 pi over 4. Question mark is equal to? Whoa, what? Okay, I will just wait. You have to do it all over again? So did I just crossed stuff out. Okay. Are we good? I guess maybe I would do a better job writing that above them. Okay, so the next one says find the complement of 30 and express in radians. So it's given the whole question in degrees, but it wants my answer in radians. Not a big deal. So I need 30 degrees plus something equals 90. Can you do that in your head, ladies and gentlemen? What's the something? 60 degrees. But it doesn't want it as degrees, it wants it as radians. So now I take 60 and multiply it by? Pi over 180. Jacob, were you going to ask, can I switch this first and then do it? 30? Yeah, of course you can. You just don't like that. It's just not professional enough. What do I got here? Pi over 3. Okay, I'm going to let you guys do this one. Complement. Is complement 90 or 180? 90. Okay. I'm going to do it. You're going to do it. Life's going to be great. Common denominators. Are you guys ready for me to show you what I got? Okay, okay, I feel better. Okay. Oh, I don't know where my answer is. Can I show you now? Okay, Danica, don't look. Good job, ladies. Good job. I like when there's high fives. Okay, so remember those fractions you guys always avoided? Yeah, they're coming back with a vengeance. Like, fractions is going to be a big component of doing this. I'm out of water. Okay, can I flip the page? No? Okay. Hey, it's only minus 17 outside.
Yeah, but it feels like 25 every village.
I was walking to school this morning and my face was cold. Can I flip? No. I love how angry you get at me.
Yeah, there's a.
Are we good? Did you get the same thing I did? Yay, you!
Minus 7 degrees is away.
I have hope. There we go. Okay. Flipping the page. We're going to talk about coterminal angles. Okay. I'm going to go right back to page 1 for a second. I'm going to go right back to page 1 for a second. Okay, do you guys remember these negative angles that the example I gave you? Okay. These are coterminal angles. Okay, so everybody just, like, it's not the end of the world. All it means is their terminal arm ends in the same place. Okay, I could go 30 degrees in the positive direction, or I could go negative 330 in the clockwise direction, and my terminal arm, it's in the same place. My terminal arm hasn't moved, right? So coterminal angles are angles that share the same terminal arm. I love it. I'm done. I'm out. This is my favorite so far today. Okay. Super easy to find coterminal angles. How'd you guys find the coterminal angle for this? How'd you find the negative angle for this? You subtracted 360, right? You had your positive angle, and you went the other way, so you subtracted 360. You did it here, and it wasn't the end of the world. But when I put a name on it, all of a sudden, it's the end of the world. Okay, to find a coterminal angle, you either add or subtract a full rotation. So if it's 360 degrees, what's 360 in radians? 2 pi. Coterminal angle are going to, they have the same terminal arm. When two angles share the same terminal arm. I don't. Okay, so now this is finding a positive coterminal angle. So are we going to subtract 360 or are we going to add 360? We're going to add 360. I call this a lot, I'm just going to write this down, I call this a full rotation. So that just means you've gone around one full time. Okay, so what are you going to do? You're going to go 60 plus 360. 420 what? Degrees. Could I have another one? Somebody want to venture out and give me another coterminal angle?
Would it be 300?
All I'm going to do to this one is I'm going to add a full rotation. So where would I be? 780. Could you do another one? Yeah, you could just keep adding 360s to it, right? So that's one, but there's many answers. Okay? Okay, positive coterminal angle to this one. So we have 120, and we're going to add 360 degrees to it. So we're going to get 480. Okay, 560. Okay, so you guys kept with the pattern, which I like, and you added 360 to it. So you have 920. Is there another one you could do? 200. Do you guys agree that 560 is more than a full rotation? Yeah. So I can pull out that full rotation from there. So 560 minus 360 gives me 200. This one makes a little bit more sense to me because I know where that is. What quadrant is 200 in? 200 degrees. Right, because it's more than 180. So if I asked you where does this angle terminate? If you can do a coterminal angle, you are all fine with knowing where 200 terminates. Does that make sense? So that's the purpose of coterminal angles, is to make them a little bit nicer to graph. Okay, restrictions are going to become your life. Okay, domain restrictions. That's what's happening here. Domain restriction there. The restriction is going to tell us a couple of things. It's going to tell us what our angles are being measured in. Are our angles measured in radians or are they in degrees? What? What are they in? Radians. Okay, I thought somebody said degrees. So the restriction is going to tell me what my units are. So this is telling me radians. But it's also telling me how many rotations I can have. Where am I going from?
0
To 2 pi. And you can include 0 and you can include 2 pi. Okay? If I put 3 pi there, you would be going around once and a half. Okay? So your restrictions are going to tell you how many times you go around, if you even go around one time. So it's going to tell you your units, and it's going to tell you your rotations. FYI, I'm a big fan of dropping the equal sign off that just to mess with you, just so you know. Like this includes 2 pi. If it didn't have the equal sign, would it include the value of 2 pi? No. Okay, just that's something I like to do, so I just want to...
It doesn't change the answer.
How would that change the
much,
answer by a lot?
Oh, no, just wait till we get into solving. Okay, we're gonna solve, in chapter 5, we're gonna solve these. Later in chapter 4, we're gonna solve these, like, we're gonna actually find angles, and we're gonna do it with radians and no calculators. Okay, it's not awful, but it can be. Okay, let's keep going with this. I want a positive coterminal angle between, so it has to be inside that full rotation. Do you guys agree that that is greater than a full rotation? What's 14 divided by 3? Let's see how good you are at changing from improper to mixed.
4 point something?
No, mixed fractions.
Four and
4 2/3, people. 4 2/3. It's okay. It's okay. We'll work on that. We'll work on some fraction work here. Can you guys convert the full rotation to have a denominator of 3? What would that be equivalent to?
Oh.
Right? Like this one has a denominator of 1. And I'm just going to take the full rotation right now, and I'm going to convert it to a common denominator, just because I know I'm going to have to subtract. And when I have fractions, I got to have common denominators. So this is a step that I do first to kind of help myself. So what I'm going to do is I'm going to pull out, for those of you, so we said 14 over 3 was equal to 4 2/3, right? Right? We get that? That's what you guys said? Okay, so what that means is I can start pulling full rotations out. 14 pi over 3, I'm going to subtract a full rotation. And we said that a full rotation was 6 pi over 3. What does that give me? Okay, good job, everybody.
Do it again.
Okay, so is that inside a full rotation? No, because my full rotation is 6 pi, so that's outside. So we're going to do it again. So I start with my 8 pi over 3, and I'm going to subtract a full rotation. So I'm left with 2 pi over 3. Is that inside? Like, is that between 0 and 2 pi? Yes.
It's kind of like doing a log.
I don't know what that is, but okay.
Log.
All right. Next one. Okay. Next one. What is a full rotation with a denominator of 6? 12 pi over 6. I like to do that first just so I know where my goal is. I have to be between 0 and 12 pi over 6. Okay, so my answer has to be in there. Now, you could do it one full rotation each time. Yeah, you totally can. Like, so that's what, so what's that going to be? What's 103 minus 12?
Oh, this is going to take
91?
Okay. So Jacob makes the good point that he's too old for this and this is going to take him forever. So you can start doing multiples of full rotations, right? So what is a multiple of 12 that's close to 91 without going over?
84.
You sure?
84 is 12
Yeah,
times
12
4.
times 50.
Right? No, 12 times 8.
12 times 7 is 84.
12 times 7 is
12
84.
times 5 is 60, 12 times 6 is 72, 12 times 7
I
is
knew it
84.
was 84.
Okay, so you got the 84. Okay, so your comfortableness with multiples. So I'm going to say, I'm going to take 91 pi over 6, and I'm going to minus 7 full rotations. So 91 minus 84. 91 minus 84. Thanks. 7 pi over 6. Does that fall into a full rotation? Yes, because you need to be somewhere between 0 and 12 pi over 6. And this one is in there. Okay. Ooh, general solutions. General solutions. Are you guys ready for this? Okay, here we go. Big deep breath. All values. This is called a general solution. Okay? So what were we doing to get to our positive or our positive coterminal angles? We either plus minus them, right? So we're going to take our angle, which happens to be 3 pi over 4, and we are going to add, what are we adding to it? 360, but what angles are we in? Are we in radians or degrees here? 2 pi. And how many times can we add 2 pi? As many as we need, right? So we're going to put a variable there. K. Okay, and then we have to define K. Okay, we're going to talk about K. What kind of number is K? It is, but it's a special type of number. Can K be a decimal? No, because what do I have to pull out? I have to pull out full rotations, right? I can whole number. And what if it was negative? Then I'd be subtracting. So K is an element of the integers.
Is it a capital K this time?
Yep. All right. So let's talk about integers. What are integers? They're positive or negative whole numbers. Okay, you could do it this way too. Oh, sorry, that should be a pi. 2 pi k, element of... Ken, what are n's? Natural numbers.
Yeah, but there's that being negative though. Natural numbers don't have 0 or...
So, but what did I add here? Plus minus.
Oh, but that's just...
This is what I use all the time. This is what I'm going to use all the time. I don't do the plus minus because I always forget one of them. Always. So this is the one I use. You've introduced a new variable, so you need to define your variable. So k is an element of the integers. All you're saying is that k has to be a whole number. It can't be a decimal, but it can be positive or negative. That's all you're saying. You did the math. Now you're making it mathy. Okay. So mathy. Okay, now we got to do the 152. So we take our angle. We're going to add, and we're adding a full rotation this time, but is it 2 pi? It's 360 because we're dealing in degrees. 360 degrees, and what do I need to do with that? Multiply that by k, where k is an element of the integers. That is your general solution. That includes every positive and negative coterminal angle for that particular angle. That's it.